The blueprint of invisible forces. How theory orchestrates simulation. The derivation sheet serves as the master architect for the entire project, providing the essential laws of nature that govern a particle's behavior within the simulation. It establishes a clever division of labor, where the magnetic field acts exclusively as the steering mechanism, bending the particle's path into a circle without adding any energy, while the electric field acts as the engine, providing the necessary speed boosts to push the particle outward. This theoretical foundation is what gives the sequence diagram its functional logic. The diagram is not merely a random set of steps. It is a procedural map that follows the rules defined in the derivation to calculate forces, update positions in high-resolution increments, and detect the precise moment for a velocity boost. By translating the derivation's steering and acceleration logic into a repeatable loop, the sequence diagram ensures the simulation engine remains faithful to real-world physics. Similarly, the state diagram relies on the derivation to define the different phases of the particle's journey. It uses the derivation's insights to determine when the system should transition from a steering state, where only the magnetic field acts, to an acceleration state, where the electric field does work. Without the derivation's most critical discovery, the magic principle that the time for a half-turn stays exactly the same even as the particle speeds up, these diagrams would lack the timing necessary to coordinate the boosts. Ultimately, the derivation sheet ensures that when the final visuals appear, they are not just animations but a scientifically accurate confirmation of how energy and motion interact to create a perfect spiral.